Pillar for CSEC Add Math. All right, it said find the range of values of x for which 2 times x squared minus 2 is greater than 7x. Now, whenever you're doing questions like these, right, you're solving an inequality. All right, let's just try to get it in a quadratic form. So if I expand in the 2 right here, I'm getting 2x squared minus 2, and 2 times negative 2 is minus 4. And if I were to bring over the 7x, it becomes minus 7x, and that's greater than 0. Aha, that's greater than 0. So this question is very easy because look at it, this is just a quadratic inequality. So if I were to rewrite it in its standard form now, rewrite the quadratic part of the inequality, I rewrite the 2x squared minus 4 minus 7x in standard quadratic form. I am getting 2x squared minus 7x minus 4. Aha! So 2x squared minus 7x minus 4. Alright? And that's greater than 0. So now all I need to do now is just factorize that part right here. Right? So I'm just going to factorize this right over here. 2x squared minus 7x minus 4. I'm going to factorize it. Now factorizing it, and this expression is of course greater than 0. All right, this expression is greater than 0, and so it is 2x and x, and now 4. Now how do I know where to put the 4? I'm going to put the 4 right here, and I'm going to put the 1 right here. And now for this part to be minus, the minus has to be here, and the plus has to be here. Because this times this gives us 2x squared, this times this gives us minus 8x, this plus this gives us 1x, and so this is fine. Now when we reach right here, so now a lot of persons get confused or flustered, they don't know what to do. Now what I want you to do is always picture like you can see the graph in your head. Right? If you were to draw a graph, so my apologies right here. So this question, remember, we had got it down to be 2x, I think 2x plus 1 times x minus 4. This is what we got it down to. Right, and I erase with the space and thing. So 2x plus 1, x minus 4, that's what this simplified to be. And it was, of course, greater than 0. And so when you get to right here now, right, what we want to do is say, okay, just picture the graph in your head. I really want us to picture the graph in our head. Right, so we have a quadratic, right, and it has roots, and the roots are going to be right here and right here. These two roots is going to be, this looks like negative a half and 4. Negative a half and 4, right? Now the part of the solution that we want is when when this right here is greater than 0. It's greater than 0 and the branch is right here. Right, these are the branches when it's greater than 0. So the function is greater than 0 when x is less than negative a half or when x is greater than 4. And so the range or the solution is, how some people would write it. All right, let's write it in the pretty form how some persons would write it. Right, the solution set as they call it. So let's pretty it up. So the solution set would be, they put their brackets, x is such that x is going to be less than negative a half, x is less than negative a half, and or comma, x is going to be greater than 4. Right? And that's the solution for this. That's the range. All right? Now, try this now. I always like to test out values. Test out a value. Always test a value to see if your solution is right. So this is the test. Test x equals 6. When x equals 6, this is the left-hand side is supposed to be greater than the right-hand side. When x is 6, we're getting 2 times 6 squared, which is 36, minus 2, and that should be greater than 7 times 6. I'm just testing if it's right. 7 times 6. Now, 2 times this part right here is 34 times 2. 34 times 2 is 68. And 68 is indeed greater than 42. And so what I can conclude clearly is yes, of course, this is absolutely right. All right. Now also try to test a value like maybe -2. Always try to test smaller values too. So test out -2. So let's test out -2. So let's test maybe x equal -2 to see if our solution will be right. Testing out -2, we're going to get 2 times -2 squared is 4 minus 2, and that should be greater than 7 times -2. Of course that's right, because this works out to be 2 times 4, 2 times 2 rather, because 4 minus 2 is 2, and so we get 4 is greater than -14. That is absolutely right. And so we can conclude that, of course, this is the actual solution. All right, so this is the solution. We know that our solution is right. X is less than -1/2 or x is greater than 4. Easy question. Now let's look at another question that's very similar to this one above. It's asking us to find the range of values of x for which this quadratic is greater than or equal to this linear expression. So again, we just need to bring everything to one side. So what I'm going to do is bring over the x squared. So look at this, I'm getting 0 is greater than or equal to, because I'm bringing everything over to this side. So I bring over the x squared to get 0 is greater than or equal to x squared. And the next thing I'm going to do is bring over the minus 4x. If I were to bring over the minus 4x here, I would get 4x minus 5x. And so that's 4x minus 5x. That works out to be minus x. So I'm adding 4x to both sides, and then I subtract 5 from both sides. Subtracting 5 from both sides, minus 5, minus 5. 3 minus 5 is -2. So I end up with x squared minus x minus 2. Now for this, I can flip it around and write x squared minus x minus 2, x squared minus x minus 2, that is going to be less than or equal to 0. I just flipped it around. All right, so when I get to this part now, I just factorize it like usual, and it's going to be less than or equal to 0. Less than or equal to 0. Now, the trick again is how to factorize this, but again, it's just going to be 2, 1, x and x, x and x. Then this is saying the signs are negative. One is negative and one is positive. That's what this is saying. So which one is negative? This times this one looks to be negative. This one looks to be positive. How do I know that? This times this is x squared. This times this is minus 2x. This times this is x. This times this is -2. So we're absolutely right. Now once you get to this right here, the trouble starts again. I want you to always picture what is happening. So draw your axis and say, okay, right here, x is -1, Right here, x is 2. All right, so x is -1 and y is 2. And so what I want now right here is when the solution is less than or equal to 0. The solution is less than or equal to 0. Remember, this is the line y equals 0. And so the solution is less than or equal to 0 when we're in between here. So we're in here. We're in this portion right here of the graph. So we're in that shaded portion. And so let's pretty up our answer now. That's the only portion of the graph where we are less than 0. So we're less than 0 in this part right here. Right? That's the only time the graph is below the x-axis. And so it makes it easy when we're writing our solution to say, well, x is such that x is really between, that looks like -1 and 2. X is between -1 and 2. Now, of course, I left off the equal to right here. And so right here, just need to underline that portion. Just need to underline right here, underline right here. So x is between -1 and 2. That's your solution. Very easy, soft. And that's how we look at solving inequality question. These are quadratic inequalities. Very easy.